Okay, great. So now that we've finished the trigonometry 1 and 2 in the textbook, we're going to now look through um, a big batch of all kind of past exam paper questions on trigonometry that'll be interesting to see a solution to. So I'm going to have a scroll through this kind of big 100-page document here and kind of pick out a few questions to go through. And before starting them, then you can pause the video and try them yourself and then watch me do them. Okay, so I've scrolled through here and I'll pick out some. Okay, so I've identified this one here from a mock paper in 2024. So we're going to have a look through this and kind of go about how do we prove what they're looking for here. So as I would have done a few of these in the textbook and showed how to do them. And the main thing that, the pitfall people can go into is they keep saying the equal sign and doing things to both sides. You don't want to do that. You just want to say work with the left-hand side and do things to the left-hand side to turn it into the right-hand side, okay? So let's just take the left-hand side. That's what LHS means. And we write that down. And we don't write that it's equal to the other thing. We're just going to do things to this left-hand side. So what's a good decision to do here? Well, 1 minus cos theta is here. And then there's a 1 plus cos theta over here. So how could that ever come about? Well, we should be okay with the idea of a difference of squares. If you have like x minus y times x plus y, that's equal to x squared minus y squared. So it's kind of one of the, most important algebra formulas. You would have even dealt with it at junior cert, the difference of two squares. The reason it's called the difference of two squares is because subtract means it's like another word for difference, and these things are squares, okay? So the hint here is seeing this 1 plus cos theta on the other side. So the idea is we're going to multiply above and below on our left-hand side here by 1 plus cos theta. And so because we're doing the same thing top and bottom, everything's okay. That's cool. So I'll get rid of this green thing now. So what will the bottom become? Well, the bottom is the difference of two squares. But what you could do if you wanted is you could multiply it out and you'll still get the same thing as if you use the difference of two squares formula. So the top up here will just be sine theta times 1 plus cos theta, and the bottom multiplied out, or using the formula, will give you 1 minus cos squared theta. And we should all be comfortable with what 1 minus cos squared theta is now at the minute, coming from this super important formula at the beginning, that if cos squared plus sine squared is 1, then if you go 1 minus cos squared, you get a sine squared, and the same the other way. If you wanted a cos squared, it would be 1 minus sine squared. Okay, so that's a big important formula there, and we're going to use that in our example here. So I'm going to swap out the bottom now for a sine squared. So dropping down, the top stays the same, 1 plus cos theta. So notice I'm doing nothing to the right side of the equation, it's just over there. I'm just doing things to the left, and the bottom becomes a sine squared theta. And the question's basically done now because this will cancel here, the squared will cancel, and so that basically equals the right hand side now. That'll be enough for the examiner to say, okay, that's good, and you write equals or HS. Right, that wasn't a bad question there, that was definitely good. Good learning. Okay, so I'll clear this away, and I'll go and I'll pick out another question from the exam papers. Okay, pause it here. Yeah, this here is a good one. So I kind of stopped at this one. I'm not going to fully go through this, but I'm just going to show you here. It says do this without using a calculator. Okay, so you're like, okay, how are they going to police this? But your calculator won't give it like this, if you were to just type it in. So there's a way. They've basically designed it so that you won't be able to get it in this format unless you do it without using a calculator. So how would we go about doing this? So 105, how does that come about? Well, you can get 105 by doing cos 60 plus 45, and you can use your cos a plus b expansion formula for that, and you just kind of sub in using your formulas in your tables book for that, basically using this one here, and that would work out. So yeah, I said that was a good one to just kind of talk through. I'm not going to solve it fully. You can finish that off yourselves if you want. So I'll keep scrolling along. Okay, so it wouldn't be going through a past trigonometry questions without doing a question like this. And these are very common. These come up in the long questions where you're dealing with a full-blown trigonometric question like this in the a plus b sine or cos cx ct. And we'll have to go through one of these. And I think this is a good one here. So we'll start off with what they give us, and then we might ask a few of our own questions based on what's happening here. So I'm just going to snip these two parts here, and we'll work through it. Okay, so we're, there's some worded stuff here, and then we ourselves have to come up with the equation down here. So we'll just kind of try and break through the words here. So there's some windmill anyways. It has blades, and the height at the tip is 20 meters above the ground. Over a period, okay, that's an important word, of 30 seconds, this point moves from 20 meters above the ground down to 2 meters above the ground. Okay, so you're kind of seeing it's going between 20 and 2, right? And then it goes back up to the 20. So that did describe its full period there if you read it carefully. So it said over 30 seconds, it goes from the 20 down to the 2 and then back up to the 20. So that for sure is the correct word there. That's a full period for this guy. So we can actually work out the C from that, but we'll just answer what they're on about here. What's the equation of the midway line and what does it represent? So the midway line, we know for these kind of say sinusoidal functions, we'll use the same name in the question, is that kind of purple line there where the thing goes above and below the purple line. And so we should be fairly okay with this. If it's going up to 20 and down to 2, the midway line will be the midpoint of 20 and 2. And what's that? That's is it 11? It should be 11. We can see a hint here anyways that it will be 11 coming up. But the way you do that in your calculator is you just go the max point plus the min point divided by 2. You're just working out an average. Okay, and now you'd actually get you wouldn't get full marks if you just wrote down 11 there. They asked for the equation, and this purple line is a horizontal line. And the way you write the equation of horizontal lines, it's just like y equals whatever number it goes through. So this is going through 11, so it's just y equals 11. So you have to write the equation like that, y equals 11, to get the marks. Right, so we know it says sinusoidal as well, and then it's saying down here that it's a cosine function. So just so you're aware, when it says something like that, it just doesn't necessarily mean that it's a sine function. So we're going to come up with this equation here, and we're going to see why it is a cosine function. So we get the hint up here as well that it begins at the highest point here, the 20 meters, and the difference between sine and cos mainly is, let me draw a sketch here. Let's say there's a midway line here. Sine will always start on its midway line, like the green line there, So this will be starting at 11 meters. Whereas if we're being told up here we're starting at 20 meters, we're starting off the midway line, like something up here. And so that's a cosine function when we start off the midway line. So that's the hint that we were always going to be working with a cos here. So if you start off the midway line, whether at the high point or the low point, you're dealing with a cosine. If you start on the midway line, like the green line there, you're a sine function. Great. So let's go through this. So let's write out what we'd expect based now that we know it's a cosine by knowing it starts at the 20, not the midway line. We would write a plus b cosine c and t. And we know it's a y as well. We won't call it y, we'll call it h because we're talking about the height of a function, but you'd be fine to call it y as well if you wanted. So you can call it h there. And we know it's t. And did they give us the symbol t? They didn't. So at the same time, you probably could have called that y and x. They didn't. This being a mock paper, they weren't very clear that the height is called h and the time is called t. Anyways, that's a small point. We'll move along. We know a is our midway line, so we can write that in there. A is 11 plus b cos ct. Now we know that this thing goes up to 20. Now how will it go up to 20? It'll go up to 20. If we study this thing I'm circling in red here, this thing can only give values of between 1 and -1, okay? At its very minimum, at its very maximum, it's going to give a 1. At its very minimum, it's going to give a -1. And you can go back and look at the unit circle if that doesn't make sense, my video on that, where I show cosine is basically just the x-coordinate of the star on the unit circle, and that goes between 1 and -1. So at its very biggest, this would give a 1, and so how would h give the 20 for the maximum up here for the blade? B itself would have to be 9, you know? That's the way that would work. And you think about it as well, when it's giving its minimum of -1, this will become a -9, and so you go 11 minus 9, and you're getting that 2-meter action there as well. So we know B is 9. So we'll update that information there. And yeah. So, and why is it a +9 as well? Because there's an option to make it a -9. So we need to study this. When t is 0, based on what it's telling us in the question, the blade begins at its maximum height. So we want h to be equal to its maximum height when t is 0. Now, when you put t in as 0 here, you're getting cosine of 0, right? And we should know that a cosine of 0 is 1. And so that's giving a +1 value there, you know? So that is its maximum, and so we want that. If they said the blade started at the 2-meter height, this here would have to be a negative, because we'd want the -9 to take away from an 11 to start at the 2-meter height for the t equals 0. Because when t is 0, this thing is always going to give a +1 value. So if you want it to be down at the 2 meters, you need to have a -9 here waiting for your +1 to get the 2. But the good news here is it's nice and straightforward. We're starting at the 20. We're going to have a +1 here because when t is 0, cos 0 will give a +1. And then to get the 20, we'd want a +9 there, okay? So I'll tidy this up. Hopefully that makes sense. You can watch that back and play it slower if it doesn't. So we'll get it all in the same color. And now C will be fairly straightforward to work out. Everyone should know their really important formula that I've been barking on about in the previous trigonometry videos. Period is equal to 2 pi over C. And we're looking for C here, so they must give us the period in either a graph or in the question. They told us the period was 30 seconds. So we just put the 30 in for period, and then we work out C. And so you multiply up by the C, divide by the 30, and you'll get that C is 2 pi over 30. And that works out as pi over 15. And so there you go. That is basically showing how they got that equation there by just using the information in the text about the midway line, the max and the min heights. One of the trickier things there was that explanation of whether this is a plus or a minus, you know, studying what cos gives when t is 0. And then also this was probably a straightforward part, you know, working out the C if you're aware of the formula. Okay, so I'm going to clear that away. Hopefully everyone's good with that. So we can draw a pretty decent graph of that, and I'm going to ask a question or two on it here. We'll make up 2 of our own tough questions on this, right? So we're going to draw a graph of this. That's probably what this question does. It makes students make a table and draw a graph of it, but we can do this fairly straightforward. So we know it goes along this midway line of 11, and we know it's going to go down to 2 and up to 20. And we know it's a cosine, and we know it starts at 20. So we're gonna start our dot up here, and we're gonna draw a cosine. There, that's 1 period, and then that's another. And two is probably enough. Okay, so this is its full period here. So that's the cosine finished up there. So we mark in the 30 seconds here that took, and then this is the other one here for 60. And that there is a pretty good graph. You just want to label this T. You can go bracket that it's in seconds. And then this is height here in meters, something like that. Yeah, do we want the brackets like that? So just, yeah, yeah, we don't want to confuse that too much. So maybe just have the, not put the units in there because that could confuse people, okay? We'll just put h and t because we do like to write functions as h of t here to mean it's height in terms of t, you know? So yeah, we'll just write h and t there, not to confuse people, having people blow up. Okay, so that's grand. That's grand. Now, there's 2 kinds of questions they can ask. They can ask easy questions here, where they can say, okay, what is the height of the blade? Question mark. What is the height when the time is 5 seconds? So what's the height when the time is 5 seconds? That is super simple. All you do is you go h of 5 like this, and you go make sure your calculator is in radian mode, but you want to type it out like this first of all on the page for the examiner. Cosine pi 15 times 5, like that. And I'll type that in here, so making sure calculator is in radian mode. Mine has to go into it, so 1 second now. So 11 plus 9 cosine pi over 15 multiplied by 5. So I'm getting that the blade worked out as a nice number, so we're lucky. 15.5 meters. And does that match up pretty well with our graph? So if we look at this, this here is obviously 15, so 5 seconds is probably tight back here. And that's looking there. And yeah, that looks pretty close to about 15.5. So the graph is definitely doing its job. Okay, that's super easy. When they give you the time and ask you the h, life is pretty easy, okay? It's not hard to get. What's tough is if they give you the height and they make you work back to the time. All right, so we're going to do that now. So, and this is probably one of the tougher questions you can get. So I'm going to pick a tough one, a really tough one out here. So I'm going to say they're interested in when, let's say there's some safety concern or whatever, and they want to know how long the blade is below 8 meters, right? So what we could do is we could use our graph here. Okay, we could draw across from 8 and we drop down and we hit the graph twice, as you can see in the first period from there around to there. So we hit it twice, and what them numbers look like roughly, I'd say that's about 10 and I'd say that's about 20. Okay, so what we would say is from 10 to 20 seconds there's this danger of the blade being below 8 meters, right? Hopefully that makes sense. Now that was using the graph. Now that was quite easy with the graph. It's a bit tougher using the function to do that. So that's what I'm going to show you how we do here. So they basically said that h is equal to 8 meters. Find us the times when this occurs. That's the question mark. So what we do is we put in the 8 for the h, 11 plus 9, cosine pi t over 15. Now we've got to find t, so t will be tricky here. And as you might remember from some of the previous videos I showed in trigonometry, these are a bit like quadratics, these cosines and sines, they usually give two values, as we expect from the graph up there. So what do I do here? So I'm going to bring the 11 over. It's going to give minus 11, so we'll get something like a minus 3 over there, and I'm going to divide by 9. And minus 3 divided by 9 is minus a third, right? So you can do that out on your page there if you want. I'm going to save some space and some time by just doing it in my head like that, walking through it. So yeah, just confirming that's minus 3 divided by 9. Yeah, minus a third. Right, so what do we do here? So a mistake here will be to go and get cos inverse of the plus of minus a third, because that'll confuse things. So what you're really wanting to do here is you want to draw the unit circle like this, and you want to draw your CAST diagram. CAST. And because cos is equal to minus a third there, you want to ask, where is cos negative? Cos is negative in this quadrant and this quadrant. So let's get our first quadrant angle here, which is called the reference angle. And the way you get the first quadrant angle, so they're just minus signs as well, by the way. This is a theta then. So I'm looking for this, what's called a reference angle in the first quadrant. And the way you get that is by going cos inverse the positive. We always work with the positive version of this for the time being. Okay, making sure now your calculator is in radian mode as well. So we go cos inverse third plus a third, and that in radians is working out at about, I'll round this, and I'll go in with the 1.23. We'll use 2 decimal places. Okay, and that's in radians. Now that's not one of our answers, that's just the theta in this quadrant. To move into the quadrants that we actually are going to get our answers from, we move into the second. The rule for the second quadrant is pi minus theta, and it's pi plus theta for this quadrant. So what our actual solutions are when we go cos inverse of the minus a third to get the pi t over 15 here, right? So our actual solutions, we can make some room for this because I don't want people to panic. So our two solutions here, I can split it up here. I have a bit of room. are going to be pi minus the 1.23. So you can type that into your calculator. So remember what I said there, pi minus 1.23. So that's working out at 1.9. So we're getting 1.9 from that. And then that's equal to what's in here because we've done our cos inverse to free this. That's going to give us our pi t over 15 on its own. The other one is when we got pi plus theta. So I'm going to go pi plus our first quadrant reference angle, which is theta. So pi plus 1.23. Hope everyone understands where I'm getting these numbers from. That works out as 4.37. And then again, that's equal to this in here because we went cos inverse of this minus the third thing by using this method here to solve it properly. And you get two solutions here, as I said, because it's a bit like a quadratic. And then there's your pi t over 15. And so if you've been kind of working on, you can pause the video here and get your 2 times here if you want, but I'm just going to do it kind of quickly. Going to multiply this across by 15 and then divide by pi, you know. So I'll do that nice and quick there. 15 multiplied by 1.9 over pi. I'm getting about 9 seconds, about 9.07 seconds. You want to have your unit a little bit further away like that. And then this other one here is working out as 4.37, so 1 second now. I'm getting 20.87 seconds there. So realistically, it's between 9 seconds and 21 seconds when there's this danger of it falling below 8 meters, right? And did we get a really good estimation of that from our diagram? We absolutely did. Remember, we estimated it to be between 10 and 20, and the actual answers were between 9 and 21. And so yeah, so you've seen now how to use the graph to get these really tough questions where they give you something like the y here and make you work back to the x. And we've shown you the algebra there of how to do it. Okay, hopefully that makes sense. You can watch that back, and then this kind of question repeats itself so much in state exams. You know, nearly every year you're guaranteed one of these kind of things. So yeah, they're a big trigonometry one. Right, I'm going to pause this, and I'm going to find some other interesting questions in this revision past paper thing. Okay, so I came across this one. This is a really important one. It's a bit of a tough one. This is from 2023's paper, and yeah, it's looking for solutions to this. So we better go through this because I think this is a good question. So we show you how to do this, right? Because a lot of people be scratching their heads here. They wouldn't know what to do. They'd be panicking, you know. So yeah, so the first thing you want to do, so realize that this is one equation with one unknown in it, t. So we're looking for t, right? So we've got to do some algebra stuff to get the t. So the first thing to do will be to get out of this double angle version. So you should be comfortable that there's a formula in your tables book for what sine 2x is. It's one of them you should just sort of know off by heart. It comes up so much that a sine 2x is equal to a 2 sine x cos x. And because we're in t's here, I'm going to write it like that. So the left side will stay the same here. And then I'm going to write this as 2 sine t cos t, right? And yeah, so one thing people could do here, and you know, it wouldn't be a great decision here now, would be just to say, oh, the sine t's cancel here, you know. You'd actually be kind of throwing away a bit of a solution there, you know. So I'll show you why. It's kind of, let's come up with an example of that. Let's say you're factorizing an equation here. Let's say x squared minus 3x equals 0, right? So you factor out the x there. This is using your algebra. And then you get two solutions here. You get the x equals 0 and x equals 3. So there was two answers. And what you wouldn't want to do is say the step before this was x squared equals 3x. You do not want to go and just be like, oh yeah, sure, what I'm going to do here now is just divide both sides by x and get rid of this, and then it's just x equals 3. You see, you'd only get one solution there. You'd be throwing away this very valid solution of when x can also be 0, you know. So it's wrong to just go and cross them out there. Hopefully that makes sense. You can read through that slowly there if that doesn't make sense. But yeah, you don't want to just go and divide both sides by sine t here because you're throwing away the valid solution of when sine t itself is equal to 0. It's a valid solution to this equation. Okay, so what we do now is we bring everyone to one side. So I'll bring everyone to the right, but I'll still write them on the left. Hopefully everyone's okay at that. There's no super panicking about that. So the sine t came over to the right, but I'm still writing everyone on the left. Now we're going to factor out the sine t. And it's going to leave behind a 2 cos t, take away 1 equals 0. So what we can do here, the solutions to this are we set each of the brackets equal to 0, but like factorizing. One solution is sine t is equal to 0, and the other one is that the 2 cos t minus 1 is equal to 0, because this is the two ways that the left side can be equal to the right side, which is 0. If you put a 0 in here, that will do it all, and if you put a 0 in here, that would also do it. And so that's what these are about here. And if you move this around here, you'll get that cos t is equal to a half. Right, so there are two solutions. So we've got to solve these now for t, because we're actually after t, as you can see here. So when does sine t equal 0? Okay, so we should know from our unit circle. The unit circle is so important. You should go watch the video on the unit circle I made if you haven't watched it. We're just tracking the coordinates to that dot there, and that dot's coordinates are cos theta, sine theta. So it's the y coordinate, and when does the y coordinate equal 0? And the y coordinate is 0 here at the minute, and it'll also be 0 here. The y coordinate will be 0 there. And what angle is that? That's when theta is 180 degrees, and that's when theta is equal to 0 degrees. Okay, because we know our angles are measured anti-clockwise like that. Okay, anti-clockwise from this location here. So hopefully everyone's okay with that. You can go watch the video on the unit circle if that's confusing. Right, so the two solutions to this here are t equals 0 degrees and t equals 180 degrees. Are we allowed to have 0 degrees? We are, because it says t can be between them two values. What about this over here? Now, are we actually missing it? This was a bit of a mean question, this one here, because it says you can be 360 as well. So what actually happens is you can spin around again. You can go all the way around. And because this dot here can also be referred to as 360 degrees, it's another solution. So it's a really sneaky thing this here. That you can also include the 360 as being the same as the 0, you know. And it's completely valid. If you go and put your calculator in degree mode and you go and put those three solutions in there, you go sine 0, sine 180, sine 360, they're all going to give 0. And so they're completely valid. But that was a sneaky one. Okay, so you'd only lose a mark out of 10 there for that, not including it. It's not a big deal. Okay, so this guy here, and this, as we've been saying before, these sines and causes, they're like quadratics. So we got to get the two solutions for this. So where is cosine positive? Because this is plus a half. Cosine is positive in here, and it's positive in here. So we get our first quadrant reference angle, which will actually be one of our solutions. And we do that by going cos inverse the positive of the half. It's already positive, so that's good. And we're in degrees now, so you do that in your calculator, you'll get 60 degrees. And then we got to move this answer into this quadrant here, which is 360 minus theta. And so the other solution then is 300 degrees. So there are solutions then, and all of them are equal to t there. That's t. Okay, so t is 60, 300, 360, 180, 0. Okay, that's a tough question there if you've never seen anything like that before, to the kind of algebra there and solving it, but it was a good exam paper question that year for those who were well studied up on it. Great, so same again, I'll pause this and I'll go find more. Okay, so I've come across this one from 23's deferred paper down here. Like that up there is just a learned off thing, you know, you can just learn that off. That's a tough one that year, the sine A plus B is tough. But again, it's just a yellow box in a textbook that you learn off by heart and regurgitate into the white space. Okay, this isn't though. We need to understand what we're doing if we're to solve a question like this. So let me snip this out. It gives us sine A, and it tells us A is between this and this. Without using a calculator, find sine 2A and cos 2A in this format. Right. So a big thing I've been emphasizing to people is that when you're given something like that up there, is that you can write that as a right angle triangle. You can put your right angle there, you can put your A here, and then because sine angle is equal opposite over hypotenuse, I can put a 2 here and root 5 here. And so I can use Pythagoras then to work out this missing side. And if you do that, it should work out as 1. Yeah, because 2 squared plus 1 squared is 5. Square root of 5 is the hypotenuse. Yeah, so that's, you can all do that there. Just anyone who doesn't know how to quickly get the non-hypotenuse side squared, you square the hypotenuse and you take away the other side squared like that. Okay, grand, that's fine. So then from this we can write out what, just from knowing this sine A, notice I haven't actually worked out what the value of A is in degrees or radians, I can write down what cos A is from the triangle. So cos A is equal to 1 over root 5, and I can also write tan A if I needed it. I could actually use tan A in this question, I'll show you how. So tan A itself is opposite over adjacent, so tan A is 2, right? And what it wants here in this question is it wants sine 2a and cos 2a. And there's multiple ways I can get that. So if we go to our tables book here, let me clear this away for a second. We could use these formulas here. We can just sub in the sine A, cos A values I just worked out there, and then that will be game over. But I also have these ones here where I can use the tan A, and I might use them for the fun of it, just to mix things up. What will I do here? Take a snip of this. But yeah, I normally will be using these ones here, and you can use them there, and you can see you get the same values, answers, but I'll use these to mix things up. So I'll put that down there, hopefully, and it'll still show. Okay, cool. So we want, we'll do sine 2a first. Oh, I want to get back my thing. There we go. So we'll do, just tidying things up. So tan 2a is 2, that's the big one here, right? So cos 2a will be equal to 1 minus 2 squared over 1 plus 2 squared, like that. And so what's that going to equal? That's going to equal minus 3 on top, and then a 5 on the bottom. Okay, so it's negative. Interesting. And then sine 2a. Sine 2a, it'll equal 2 times tan a, which is 2, over 1 plus tan a, which is going to be 1 plus 2 squared, which is 4. And so that guy's working out as 4 over 5. So we got our two guys there. Now, do we have to be worried about anything here? But I think that should be okay. But we'll have a think about it. The only thing that might be worrying people is the fact that that's a negative, and then they said this condition up here, which is a bit interesting. That a can only go between 0 and 90. But that should still be okay, because if you double a, and a was something like 60 degrees, it ends up in the second quadrant. And in the second quadrant, we know second quadrant. Oh, you can't see that little diagram I done there. You could just about see that there. Yeah, that was 1 plus tan squared a. You're okay with that. Okay, so the idea is here. Why is it okay? So, because we have our cast diagram here, and if a was something like 60 degrees, because it says it's allowed to be between 0 and 90, if it was something like 60, you double it as it is here with a 2a, you'd end up with like 120 degrees, and that'll put you in this quadrant here, which will give you a positive sine and a negative cos, and that's what we've got up there. And so that's assuming a was something like 60 above 45 degrees. And sure, we'll work out a there just to double check. We're not supposed to use a calculator, but we'll do it anyways just to see what happens. 2 over root 5. I want to go into degree mode. So sine inverse 2 over root 5. Yeah, so it's working out at 63 degrees, so both of them are completely valid. So that's happy days. Okay, right, we'll move on from that. The triangle thing that I showed you there was probably the main learning for you there. Okay, cool. So I'll find another question. Yeah, so I was just moving through it here. We're kind of just over a quarter or whatever of way through this big PDF of all the trig questions. And this one here is very similar to the one I just solved there a moment ago, where it was between the 0 and the 360. and you can see there it's near identical. It's just literally moved around, and you'd put that in as 2 sine x cos x, and then of course there's still your minus cos x there, equals 0. You factor out your cos x, and you get the 2 sine x and minus 1, and it's really close to the question I just solved there earlier. So just to see the bit of repetition in that there. Right, there's a part 2 to it up here, so I might have a go at that because that looks interesting. Let's see what I'll do here. I try and keep them both in screen. The diagram shows parts of 2 trig functions. Yeah, there's your sine 2x, and there's the cos x shown between 0 and 180. Use your solutions in part I to write down the coordinates of P. Right, and yeah, so why would part of our solution give us the coordinates of P? So when it says coordinates as well, it doesn't just want the y value, it wants, what is the x coordinate in degrees and what's the y coordinate from the y-axis for P there. So we can see it should be something there, maybe if that's 90 and 180, maybe this is around 140, 150 degrees, something like that. And because sine and cos go between 1, so that lowest point there would be 1, so this might be something like 0.9, 0.8. Okay, but we need to work it out using the algebra. So why is this related here? Because you could move this around. So one of the functions could have been y equals sine 2x, and the other function could have been y equals cos x. And when you set 2 functions equal to one another, you're finding their point of intersection. And so what you would do then is you'd go and you'd use your algebra on this to find the x value that makes them equal. And the next step here would be to bring the cos x over like they done up there and solve it, which would be the B part I fully solved there. So yeah, so hopefully that makes sense. And you'd get, as we've seen there might be something like 4 or 5 solutions, and it'll be the one that's closest to about, as you can see here, 150 degrees. And about the one that's closest for an x value of 150 degrees. And so let's say one of them was 150 degrees. You got a solution when x equals 150 degrees. You wouldn't just write that down, you need to write the coordinates. And so the coordinate, you need the y coordinate as well there. And so you can sub that into something like cos. So it'll be like cos 150. And whatever cos 150 gives, it'll be that value there. So that's minus 0.9 as well. Okay, hopefully that makes sense to everyone. I'll keep moving along. It's not too hard given what I done before. Okay. Yep. So just rolling through this here. This is one of the rare ones where they give you a big hint here. They said product of sine and causes here. So you can, if they didn't say that, if they just said express this in terms of sines and causes, it would be a little bit tough on students because sometimes they might go and see that 3 theta there. And they'd say, oh, that's 2 theta plus theta. And then they'd go and waste some time then on the expansion formula for sine A plus B, But there is actual formulas for product sums and differences in your tables book that will help a lot with this guy here. So I'll clear that away just to show you this. So we go over to our tables book, and then we go to the next page here, and we get these products, sums and differences. Okay, so we want to move into a product, so we're going to use these ones here. And we have a sine 3 theta and a sine theta. So A is 3 theta. It's always good, but when you sub into these, to say for yourself what you're putting in. So that's that, and then that's that. So then what we're getting is 2 sine 3 theta plus theta over 2. So that'll work out as a 2 there. Yeah. And then this is a cos 3 theta minus theta over 2. So that's just a cos theta there like that. And then what we'd have here, so that's, let me see, can I make this bigger? I can. So that's what that became there. That became 2 sine 2 theta, sine 2 theta cos theta. And what you might do here as well, you'd swap out the double angle. You should all know, I think I spoke about this earlier in the video, that one is 2 sine times cos. Like that. There. That's swapping out the double angle. And so you get 2, it's 4. 4 sine theta cos squared theta, right? And that's how that works out there. Hopefully that makes sense. Let's go back here to the question. So then it wants you to solve this thing by setting it equal to 0. So and then it wants the answers between there and there. So let's see, can I get that snip there without everything blowing up? Yeah, so you done the algebra there, and then you got this thing down, and then it says set the thing equal to 0, right? Set the thing equal to 0. So what you could do here is you should know that you can swap cos squareds out for 1 minus sine squareds. So I think I spoke about that earlier in the video as well. So 1 minus sine squareds equals 0. So then this gives a 4 sine theta minus 4 sine cubed theta equals 0. Now you could probably divide out the 4. There's no need for the 4 here. We can just get rid of the 4. The 4 is just tagging along for no reason. We can get rid of it. So now we have sine theta minus sine cubed theta equals 0. And so we can get some solutions for this. So how would we do it? What you could do here is you could call x equals sine theta. And so now this looks like a healthier thing. It's like x minus x cubed equals 0. So people know how to factorize this a bit better. So then it's x bracket 1 minus x squared. X squared equals 0. You should know that the difference of squares. So that's x bracket 1 minus x times 1 plus x. And so the solutions here are x equals 0. Oh, I have to keep my 0 here. That's x equals 0. It's x equals a plus 1. And then it's an x equals a minus 1. So 3 solutions, but that's what we'd expect because this was a cubic up here, you know. And so we have loads of solutions to that there because remember x here is sine theta. So we're asking ourselves, when does sine theta equal 0? When does sine theta equals 1? And when does sine theta equals minus 1? And we should know this is all unit circle stuff now because we know our unit circle. We're literally just tracking the y coordinate of that dot there. And so when does that dot take on, did I write something silly there? That looks like a theta. That's a 0. So when does the y coordinate take on a value of 0? There and there. So the two solutions there are theta equals 0. Theta equals 180 degrees. When does it take on a value of 1? That's up there at the 90 degrees. So this is theta equals 90. And when does it take on a value of minus 1, the y coordinate? It's down there. And so that's theta equal to 270. So that was a really good question that year. It got the products, sums, and differences out, and then it also got this kind of algebra stuff out. So that was a good question there for students. Okay, I'll clear that away. I'll pick out some more. Yeah, so these come up. These are really common. These are like every second year kind of thing. And I know I went through these when I was doing my tutorial videos on trigonometry, but just in case anyone didn't watch these are just so common in exam paper questions. And this video is about looking at past paper questions on trigonometry. So it's really important students see how to solve these questions, right? It's a shame this one is in degrees. I prefer working in radians because it just makes it a little tougher to see. But yeah, I can absolutely force the issue here. I can just say this is between 0 and a 2 pi, and then you get your good learning from this. Okay, so how do we do these questions when they come up? So there's a rule, there's just a general thing that happens. If this thing is just an a here, there's just going to be 2 solutions. It's a bit like a quadratic. If it has a 2 there, there's going to be 4 solutions. And if it has a 3 here, like it does now, that's kind of the biggest value they'll give you, it'll have 6 solutions, okay? And if you do enough of these and you've practiced enough, you'd see that that happens. Right, the big thing here that you got to do is you got to understand, first of all, your CAS diagram, right? Your CAST. We know our sign here wants to be negative. Where does sign be negative? It does be down here and down here. So to get down there, we need to get the first quadrant reference angle first. And the way we get that theta is by doing a sine inverse the positive. We always work with the positive of this first so we can get the first quadrant solution. Now that when you set your calculator to radian mode, or you should know this one yourselves off by heart, that's a pi over 3. That's the 60-degree solution when sine gives that. Anyways, that's pi over 3 in this quadrant here. Okay, so what's the rule to get down here? It's pi plus theta to move into that quadrant and 2 pi minus theta to move into this quadrant. So when we move it in here, pi plus pi over 3, that's working out as 4 pi over 3. And then 2 pi minus pi over 3, that's probably 5 pi over 3, if my calculations are correct, which I believe they are. Yeah. Okay, so what are we doing then? So there are two solutions. So we're really looking for this 3a here. So 3a is on its own now. And so this is what we do. This is the big thing. We split the page down the middle, like this. And we say our 3a is equal to these two angles, these two solutions we got. 4 pi over 3 and then 5 pi over 3. This is similar to what I done earlier in the video with the windmill. And now, so we want to get what's called the general solution here first. So what we do is we add on a 2 pi n because this accounts for multiple spins around the unit circle. We don't want to just spin around once and get the solutions just for one period like we did with the windmill. We only wanted one period then for when it fell below the 8 meters, if you remember that. So you add on the 2 pi n here. That's called the general solution now when I divide everything by 3. Okay, so if you were just asked for the general solution here, this would be where you'd leave your workings. 4 pi over 9 plus 2 pi n over 3. And then a equals 5 pi over 9 plus 2 pi n over 3. Now, that's the general solution, but we weren't asked for the general solution here. We were asked for specific solutions between 0 and 2 pi. So what you do now is you start at n equals 0, and you put 0 in for n. So your first solution will be 4 pi over 9. It'll be 5 pi over 9 here because n is at 1. N is at 0, sorry. N is at 0. Slip of the tongue. Okay, now we set n equals to 1. And we'll get a equals. I might use a calculator here to get these correct. So I want to write something silly down. 4 pi plus 2 pi over 3. So I'm getting 10 pi over 9 there. And then over here when n is 1, I'm getting, because it'll be 5 pi over 9 and 2 pi n over 3. So that's working out. 11 pi over 9. Now I ran out of space here, but if I had space underneath here, I would do n equals 2. Let's see if there's any way I can make a bit of space happen here. There should be. Don't want it to get too small now either. All right, n equals 2. Might use a different color for this. So that's a is equal to 4 pi over 9 plus we're putting a 2 in there for the n, you know, that kind of thing. So that works out as I wouldn't usually write that out there, you know, because the examiner knows you're putting 2 in for n by me writing on the left there that n equals 2. So I don't want to waste too much time here now on this. I want to keep the video fairly short. So that's working out at 16 pi over 9. So you see that number is still below 2 pi. Study it carefully. 18 pi over 9 would be over 2 pi. And then the other fellow over here, I'll just do it quickly. If you put a 2 in there for n, and you go 2 pi times 2 over 3 and add on your 5 pi over 9, you'll get 17 pi over 9. You see it's just below 18 pi over 9, which is 2 pi. And that's our last solution there. If you put n equals 3 in there, your solution will go above 2 pi. And so that's not one of your answers. So just circle them up then for the examiner. This is one of them. 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 So this one. And then that's that one. And so they'll just look at that and tick it. Now, the great thing about these questions is you can be 100% sure you got full marks here. You can go and test all 6 of those answers by putting them into sine 3 empty bracket and have your calculator in radian mode and put all your solutions in there for the empty bracket. Now I'm going to just test 2 of them. I'm going to test the very first one and the very last one and make sure they give me a value of this here. It's like, you know, when you solve a quadratic, you could be asked verify your answers. So that's where you put your 2 roots back in to see if it gives 0, that kind of thing. So we're checking, do we get minus root 3 over 2 for all them orange answers. So making sure you're in radian mode, and then going sine 3 multiplied by 4 pi over 9. I do get minus root 3 over 2, which is good. And then checking the last one, which is 17 pi over 9. And that also gives me minus, when I check the 17 pi over 9 here, I got the minus root 3 over 2, and that would work for all 6 of them. So I know for sure I've got this fully correct, and I can move on happy in my exam. Okay, they're very important. They come up like every second year, you know. They're very common. So I'll pause this here and keep going. Yeah, okay, so I was scrolling along. So I like this question. This is a smart question this year because they put in like a y over 2. They didn't go like 3 over like 10 or something like that, where the student could actually go and work out a by going cos inverse that. Just notice I said 3 over 10 there. Notice I didn't say cos a equals 3 over 2. Okay, cos can never equal 3 over 2 like that, because cos can only give values between 1 and minus 1, okay? And that's 1.5. So if you tried to do cos inverse of that, you would get a error, okay? Sound. Right, so we're going doing this here. So the question is, how do we do this, okay? It's got the y in it there, you know? So it's going to be the triangle again that I've done earlier on in the video. So what we do is we draw a triangle. Yeah, that's recording there, good. So we put the a in there. And then we do, cos this is cos, so this is adjacent over hypotenuse. Very good. And then we use our Pythagoras to work out the missing side. You can do that yourselves. It'll come out like this. And from that then, all we were given was a cos A. We can actually work out what sine A is. So sine A is equal to opposite over hypotenuse. And we could work out tan A if we needed it. Tan A would be opposite over adjacent. So that's 4 minus y squared all over y, doing that neatly. Okay, so how do we get sine 2a? Well, that's one of the things I've been hammering home for you to kind of remember off by heart. It comes up so much. Sine 2a is 2 times sine a times cos a. But sure, we have both guys now. This is 2 multiplied by what we just found there, square root 4 minus y squared all over y. And then cos a is is y over 2 from the question. And then what happens there is the y's cancel. Oh, look, the 2's cancel as well. And so the answer here is just square root 4 minus y squared. And that was a really smart question that year. If you don't know about this triangle thing, you know, you're a bit goosed. But now you know about it, so you shouldn't be goosed. Okay, cool. You can pause that and rewind it back there if it was too quick. Okay, I'll keep going. Yeah, I was scrolling along here, and I know we've already done one like this. Where we get the values between 0 and 360, and there's usually 6 values if that's a 3, you know. I just said I'd do this one because it's a tan, you know, and people are so used to them being sine and causes, they're not that used to them being tan. So we'll just show that there's nothing really different because it's a tan, you know. Tan is one of those things. Tan theta can absolutely give a value like 3 over 2. It can go over 1 and minus 1. Tan is able to give, because if you know your graph of tan goes all the way up to like infinity and like minus infinity, okay? So I done a video on the graphs of the trig functions and their ranges, so you can go back and look at that if that doesn't make sense. Okay, and another thing you should know as well too is tan theta is when it's equal to 1, theta itself is 45 degrees. That's one of the most common things that you'll see is that tan 45 is 1. So that's just to be aware of. Anyways, we'll do this question here. So we have tan and it's working out as a 1. So that's positive. So where we do our cast diagram, where is tan positive like that? Tan is positive in this quadrant and in this quadrant. So we get our first quadrant reference angle by going tan inverse the 1 here. And because we're in degrees, make sure your calculator is in degree mode, you'll get the 45. And this is actually one of our solutions here because we want the positive tan. And so the other one is in this quadrant. And the rule for this quadrant is 180 plus theta. And so that would work out as 225 degrees. So then again, this is just us splitting it down the page here, like this. And then we go 3 theta, because that's inside there, is equal to 45 degrees, and it's equal to 225. And then we add on, not 2 pi n this time because we're in degrees, we add on 360 n. And it's only after we've added on the 360 n that we divide by the whatever numbers there, whether it's 2 or 3. And I'm getting 15 plus 120 n, and then that's equal to, what's that? That's about 75 degrees. 75 plus, have I divided that by 3 correctly? I have. So that's 120. And so that there is the general solution, but we're not asked for the general solution here. We're asked for all the solutions between 0 and 360. So you just go n equals 0, n equals 1, n equals 2, and get the 6 solutions. And you can do n equals 3, and you'll see one of the solutions goes above 360. It might be like 400 and something, or 375. Okay, cool, 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 cool. That was important for people there. See, the tan works the same. Okay, I'll pause this. Yeah, so we're getting to the end of the document now. There's not that many that I haven't done that's kind of unique. I think I like this one over here from 2016, so we might do that one. So that looks crazy stuff here. Like, they're talking about cot here. What madness is this? So you'd have an awful time here if you didn't realize that there's them products and differences formulas, Without them here, you just wouldn't be able to kind of get through this. So it's using these here to our advantage. These'll get us through this question here. So let me kind of move that up there so everyone can see it. Okay, so we've got a cos plus a cos, and we probably want to turn that into a product. So this would be this guy here. Again, too good to name out what your A and B are because they can get confusing. See how A, the name is already taken up here. So A for the one on the top is 7A. And then the B is just called A, so it can be a bit confusing. So then what the top of that there is going to be, again, we're asked to show this, so we're going to just work with the LHS for the examiner. So we'd write this out here. I'm not going to waste time doing it. I'm just going to sub it in here. So cos 7A plus cos A will work out as 2 cos 8A over 2, which is 4A. And then this is going to be cos 7, so that'll be 6A divided by 2. That's going to be a cos 3a. Right, on top, now we have a sine take away a sine. That'll be this one. Sine take away sine. That's going to give me 2. Thankfully as well here, the A and the B are still the same, so that's handy. We don't need to change this instruction here. So then that's working out as cos A plus B, so that's a 4A, isn't it? And then we have a sine A minus B, so that's the 3A because it's 6A over 2, Now what cancels here? The 2 is gone, the cos 4 is, so we're just literally left with cos 3A over sine A over sine 3A. And if you go and you look at the definition of what cot x is cos x over sine x. And I'll show you where that definition is here in your tables book. There it is, cot is cos over sine, And so we've got a cos 3A over a sine 3A, and so that's going to be a cot 3A. Okay, great. So I'll keep scrolling along through the document. That was a good question there. So be aware of those sums and differences formula if they come up in your exams. Yeah, actually, just the one underneath this is actually quite interesting. So I'm going to do this. I'm going to do this with people. So they're giving us the cos 2 theta, and they want us to work back to the cos theta. So the first way I'd recommend, now you might fall in the trap. I was like, ooh, I'll draw a triangle for this, and you could. But the smarter thing to do here is to actually know off by heart what your cos 2 theta formula is, just like you should know the sine 2 theta formula. I've been emphasizing quite a bit in the video. So cos 2 theta is a cos squared theta minus sine squared theta, right? And that's equal to the ninth, as they say. Now we should know that we can swap sine squareds out for 1 minus cos squareds. Okay, so that's something I mentioned earlier in the video. Times 1 minus cos squareds. And now if you look at it, I have the ninth in terms of the thing I'm after, which is the cos theta. And so let me go and multiply that out there. If you do the multiplication, that goes minus 1, and then that'll be a plus cos squared theta. Add that to this one, and you get a 2 cos squared theta minus 1 equals the ninth. Might bring the minus 1 over and divide by 2, doing lots of steps in one go. I'm sure you can all do this slowly in your copies. You add 1 to a ninth, you'll get 10 over 9. You then divide that by 2, and you should get 5 over 9. Right, so cos squared theta is equal to 5 over 9. And always when you're taking square roots, you know, if x squared is equal to 9, x does not equal 3, okay? It's equal to plus or minus 3. Okay, don't be the silly students that are taking square roots and not going plus or minus. So here we have the cos squared is 5 over 9. So then cos theta is plus and minus root 5 over 9. And that simplifies down to root 5 over root 9, which is the bottom can be just come 3. So 5 over 3 like that. Cool. And yeah, that's the format they wanted. Okay, that was good. That was good to just see there how to the process of that there. What was the correct move? Right, I'll clear that away. I'll keep going. Yeah, now I know this one's really easy over here, but it's just such bread and butter trigonometry, and I've already shown solving stuff like this earlier on in the exam and the harder questions, but it's just good to maybe emphasize it here again. It'll only take 60 seconds for me to go through this. So we're looking for two values of a. So I've said before that these are a bit like quadratics, you know, they always churn out two values for us, you know. So when you're solving this here, you don't want to go, what you'll do first of all is your CAS diagram, C, A, S, and T. And because sine is negative here, you'll identify that sine is negative down here and here. To get those two solutions, you want to get the first quadrant reference angle. The way you get the first quadrant reference angle is by going sine inverse, because this is sine, the positive. You always work with the positive version of that thing, just so you can get in the first quadrant. You do that, making sure your calculator is in degree mode for this question. Sine inverse 0.6293. I'm getting about bang on 39 degrees. It's not far off. Okay, so theta is 39 degrees. That's not one of our answers though. We've got to move it into these quadrants, and the rule to move into this quadrant is 180 plus theta. And then this is 360 minus theta. So our actual answers here are 219 degrees and 321 degrees. If I've done that correctly in my head. I think I have, yeah. Yeah, it's just, yeah, you're happy with it anyways. 180 plus 39. Okay, there are the solutions there. And how do we know they are correct? Well, you can go and put them back into the original thing to make sure they produce this answer. We've done a little bit of rounding of the 39 degrees, so they mightn't give exactly that number. So we'll just do it anyways. So go sine 219, making sure you're in degree mode. And yeah, I am getting that number. I'm getting this number up here when I go sine 219, like checking my answers, and go sine 321. And I get that answer. So I am sure both of them are perfectly correct, and I can move on happy knowing I found it. Okay, that's such bread and butter trigonometry to know how to do that, where you go like sine inverse, cos inverse, the positive of that, get the first quadrant, and then move where you need to go, you know. And that I said I'd stop for a minute or two to just emphasize that. Okay, right, I'll keep going. This document is pretty much done. I don't know if I'll find another question. Yeah, so I've reached the end. I've scrolled through all that past paper trigonometry stuff from state exams and mocks, and I'm happy I've kind of covered the main stuff, you know, that could catch people out. So just be aware of these long questions. You know, you're nearly guaranteed one of them in your exam. And I've already kind of gone through one of them up there with the windmill. You know, they're just so important. And I'll just spend maybe, you know, this is a long video. It's already an hour, so I might just spend, you know, three minutes just talking through the realities of this one here, the kind of questions that could get asked on it again, just so everyone knows how to deal with these big functions when they come up. So there it's saying there's an F and there's a T. It's saying T is in days, and then F is, what is F? F is the length of the day, so it's probably in hours, is it? Yeah, it probably is in hours. They don't tell us. Or it is, yeah, something like hours and minutes. Yeah, the length of the day. I imagine F is in hours. Okay, you read that slowly if I've talked through that quickly. Okay, so what is it telling us here? We could be asked a few different things about this question. First thing we could be asked for is what's the period of this function, right? We've been given the function and we're asked the period. So we've got this all important formula called period equals 2 pi over c. If for some reason the function was in degrees, this will be 360 over c, right? C, just so we're all good with it, these functions are usually a plus b sine cx. So c is the thing in front of the t here, and it's all of this in this question. So the period of this function is going to be equal to 2 pi all over the c which is 2 pi over 365. You can type that into your calculator, but you should be okay with that. That cancels and the 365 goes up there if you're half decent at your algebra. And so the period of this function, if it was asked, is 365 days. So yeah. And t, they said t, approximate length of the day in hours. Okay. Yeah, so F is in hours and T is in days. Yeah, so that's good. And so that has units there of days. Okay, so we've done the period thing. Another thing you could be asked for is the range of a function like this if you're given it. So the max and the min value. So the midway line for this as well, you could be asked the equation of the midway line. So that's you have to write y equals 12.25. And then what's the maximum value this can have? Well, it'll be, if I circle this thing, what values can that thing take on? It can go between 1 and -1, as I spoke about earlier. Signs can only give between 1 and -1. And so the biggest value f could have is when this takes on the +1. So then it will be 12.25 plus the 4.75. The minimum value this f could have is when it takes on the -1. And so that will be the 12.25 minus the 4.75. Okay, so then let me type that into my calculator. 12.25 plus 4.75. So the biggest value it can have is 17 hours. And the minimum value it can have here is, these are, bread and butter stuff. So it's good to go over this, 7.5. And that, seems like a reasonable question. The longest day you could have has 17 hours of sunlight. And then the shortest kind of a wintry day might be the 7.5 hours. So I've done the midway line. I've done the range. And if you're asked what the amplitude is just the 4.75 number. And then you could be asked then to draw a graph of this here, So let's draw a graph of this. And I think that's everything. You draw a midway line here. Midway line is 12.25. It goes up to 17. Goes down to 7.5. It's a sine function. And it's a positive sine function, so it always starts on its midway line and then goes up the way, and then it comes down, and it goes back up like that. I didn't draw that to scale, so I think my main issue here is my midway line should come up a touch, and up you go, and down you go. Okay, that's happy. And then, as you can see there, that should be the 365. 365 days, and then this is when t equals 0 at this moment here, and then just label this axis as t, and then this here is the length of the day in hours or whatever, they call it f of t, but maybe the better thing is h for hours. Okay, and t this then is in days. This is the days of the year that we are from, starting here from the March 21st, whatever that is, the spring equinox thing. Okay, right. I won't waste any more time there. That was short. So yeah, and yeah. So this here, I said the word amplitude, didn't I? So that there is what they would call the amplitude there, and that was 4.75, 4.75, as we can see there. 4.75. Okay. And yeah, of course, the tough questions come. Everything's really easy. If they give you t, they say t is 100 days, work out what day life there is, then you just put the 100 in and let the calculator do the work. Things get a little spicier then when they give you something like, okay, what time of year do we get a day that has 10 hours? And you can use your graph like this. You go over and you pull up and you measure off the values, whatever it is. It's 300 days after March 21st. And because that's 1365, so it's about 180 days there, so this is maybe 200. So there's 100 days of the year when the daylight is less than 10 hours. And then I've shown earlier in the video with the windmill how to go and actually work that out using the algebra. Okay, so hopefully that's everyone prepared for the trigonometry questions that can come up. That's a good flavor, a good mix of the stuff that can come up for you. Okay, right, great stuff. Thanks for watching, and yeah, best of luck.